Okay, so I think we're recording now, and I haven't figured out how to make this go away. That makes it get oh, I can collapse it and then make it bigger like that again, I suppose. Okay, so I think that we're ready to dive into some C++ now. I have the dev C++ IDE open. IDE is Integrated Development Environment. If you're on Windows, you'll be using either dev C++, or if you want to, Microsoft C++, what's it called? Visual C++, yes. And I've got instructions for both of those in the syllabus. If you're on a Mac, you'll be using Xcode. They're all kind of the same. The one nice thing about dev C++ is that for beginners, it's nice because in both the Microsoft product and in Xcode, you have to create a project, and then you have to like add your source file into the project and some other things. So it's a little more complicated. With dev C++, the first time you write a C++ program, you just type it in and hit run, and that's all there is to it. So I'm gonna just do that for today. Question? Do I have one for Linux? I don't know about IDEs for Linux. I'd have to think about that. I mean, I know when I'm on Linux, I just use the command line compiler, but there's probably a better way to do it. Yeah? I don't think that's a C++ compiler. Yeah, I think that's okay. All right. So I'm going to just click on File, New, Source File, so that we've got a file here that we're going to create our program in. Okay, first C++ program. This is where I open my notes. So the first thing that I'm going to show you how to do in C++ is just to write a message on the screen. Okay, how many of you have maybe learned another programming language or something, and so you know what the example is I'm about to do? What am I going to write on the screen? Hello world. Okay, that's kind of the standard thing that people write the first time they write when they're first giving the first example of a very simple C++ program. So here's how it works in C++. Let me see if I can make that bigger. No, that's search. Well, I think I'm looking for like a font. Yeah, that could be compiler options, editor options, font size. Let's try 14. How's that? Is that better? You know, can I get someone to maybe close that door and turn off one of those the light switch that controls the front lights here? Thank you. All right, good guess. Okay, see out. Okay, there's your basic C++ output statement. That's how you get something to appear on the screen. Already, even with just this statement, there's a lot of technical details that I can talk about. Okay, there's basically 4 components that you'll see here. You've got the word cout. You've got this thing right here, which has a big fancy name, but I'm going to tell you the name because if you understand the name, you'll understand what it's doing, I think. Okay, it's called a stream. Stream insertion operator. Okay, it looks like we may be out of seats. You're welcome to either stand or maybe grab a seat from a nearby classroom if you want, whichever works. Okay, sure, that's fine. Yeah, 11:50, right? Yes. And my microphone keeps dropping. So, all right. So it's called a stream insertion operator because what it is doing is it is saying, take this thing over here on the right and insert it into this stream over here on the left. Okay? So it's when you look at this, you're probably thinking, okay, the action word here is see out. That's kind of the natural thing that students do when they first see it. The action word is see out, and you're saying see out something, like see out this string. Okay? But actually the action part of this statement is this. It's an operator. Okay, think of it as like if you had a plus sign there, the action would be add the two operands together, right? This is an insertion operator, and it's saying take the thing on the right and insert it into the stream that's on the left. Questions about that? Does that sound too complicated already? Sometimes when I teach this, I don't even explain that because I don't want people to start having their eyes crossed right in the first 2 minutes, okay? But I think that should be understandable. Question?
I understand. Can you explain about see out?
See out, basically the way you should think about it is that it represents the computer screen or the console window. And the way C++ does input and output is it kind of, you talk in terms of these things called streams, in an input stream or an output stream. So kind of think of that as something that's sort of in between your program and the computer terminal. So I am telling my computer to put this item, insert this item into the output stream. So it puts it into the output stream, and then it goes from the output stream onto your computer display. Well, so that's exactly what I'm trying. I mean, it's a lot of times you think of cout as being a function that does something, but actually cout, technically in C++, cout isn't the function. Cout is an object. It's a thing. Okay. The function, use the word function, so I'm going to go with that. The function or the action word here, the command here, is that operator. And the operator is saying, take this thing over on the right and put it into this thing over on the left. Okay? If it works better for you to think of cout as the function word, I'm okay with that for now. But eventually you're going to have a more nuanced understanding of it. Yeah? No, what's going to happen is there's going to be a console. It actually depends on your IDE a little bit. But in our case, I believe what's going to happen is you're going to get a little black console window, and it's going to show your output in there. Okay? The bad news is, for this class, is the actual programs that you're going to be writing are not going to be really fancy in terms of like what they produce. Okay? Everything we do is going to be in the little console window, because that's the best way to keep things simple and learn programming. Okay? So, for those of you who get motivated by that kind of thing, my apologies in advance. It's going to be pretty boring in terms of what your programs are going to do. Although you can do some fun things in the console window too. But all right. What else do I want to say about this? We covered the stream. This is an output stream. Hope I didn't say input stream before. It's an output stream, right? This is the stream insertion operator. This thing here, the third item here that you see, is called a string. I think probably most of you who've used a computer aren't too surprised by that. In C++, strings are always surrounded by double quotes. Okay, so anytime in a C++ program you see something in double quotes, you know that's a string. And any time there's a string in C++ code, it's surrounded by double quotes, so it goes both ways. Yes? Yeah, you're right. There are. String, S-T-R-I-N-G. Okay. And stream, this is an input stream, S-T-R-E-A-M. And it seems like there's one other similar sounding word here that I can't remember what it is. String, stream. Oh, maybe it'll come later. I always remember that when I do this first lecture, there's three words that sound very similar that I have to keep straight. Screen, that's the other one, screen. So this is going to appear on your computer screen. I just looked down at my notes and saw the word screen. Okay. Any questions about strings? We'll talk about a lot more about them later. Yes?
So it's the string that you're inserting into the stream.
Correct. It's the string that I'm inserting into the stream. Thank you. And you guys, actually, I just realized that I haven't been repeating your questions, and I really need to do that for the recording, so feel free to remind me if I forget to do that. Okay, and then, so that's three components of this statement. The last component of this statement is this semicolon, and that's pretty simple. It's just the case that all C++ statements end with a semicolon. Okay? All right, so there's our output statement. What we'd like to do is actually execute this program and see what happens. Okay? But in C++, you can't just type a statement by itself and expect it to anything to execute. Okay? You have to embed it into a complete C++ program. So what I'm going to do is I'm going to type the rest of the stuff that we need kind of around this statement to make it into an actual real C++ program. And I will explain a little bit about what's going on with it, but basically what you need to know at this point is just that you copy it and use it as a template. Does that make sense? And then there's a certain place in the template where you stick your statements, and that's all you need to know at this point. That's what the IDE does that automatically. The bold words are reserved words in C++. Integrated Development Environment. Although I saw someone use IDE the other day and explain what it meant, and they had a different word for the letter I. And I was like, is that right? So there may be two different ways that people use IDE. Integrated Development Environment. Yeah. Yeah, the program we're using. What was that other word? I can't remember now. All right, so we're done now. That's a complete C++ program. And all we need to do, now if you're using Xcode or if you're using Microsoft Visual C++, which you can download the Express version of for free, and that'll be fine. Or if you're using Dev C++ and you want to create a project, which probably isn't a bad idea to just get in the habit, we wouldn't be done. We'd have to create a project, and then we'd have to add this file to the project, and then we would execute the project. Okay? In Visual C++, they actually take it to another level. You insert the file, the source code is part of a project, and then the project is part of something they call a solution. So that can be a little bit overwhelming when you're just trying to write your first C++ program that has 2 lines in it. All right, so execute, compile, and run, or F9. Okay, it's asking me to save my source code. That makes sense. I should probably save it. I guess I'll just save it on the desktop for now. I'm going to call it 1.cpp. Okay, compiling. Okay, so what just happened is it actually ran successfully, and well, it doesn't tell me that. But if you were watching closely, you saw a big black box flash on the screen and then disappear. Anybody see that besides me? Okay. That was our console window, and unfortunately it's gone now. So we can't really tell if our program worked or not. Here's what we can do. And this is you should not put this statement in unless you know that your IDE works this way. Different IDEs work differently. Some IDEs, that would have worked just fine and the console window would have stayed there till I closed it. I can't remember how Microsoft Visual C++ works. You'll have to just try it. Okay. But for Dev C++, we have to put in this system function call, which I cringe out a little bit because I'm kind of a purist, and that's a operating system specific function. So if you take this code and try to run it on a Mac, it won't work. But that's what we have to do to make it so we can see the console window. Okay? Let's try it again. Execute, compile, and run. Whoa. There's our console window. Any questions about that? Question in the back, sorry. Right, right. So for an Xcode, or if you're using a Mac, I'm pretty sure that you will not need that system pause. You can just leave it out. Yes?
The main function usually has the end return 0.
Ah, good question. So somebody has heard that the main function usually ends with a return 0. Why didn't I put that there? In C++, technically, if you don't have a return statement in main, the compiler automatically puts one there for you. So it's automatically going to put a return 0 in for me. So I think if it's going to do it for me automatically, why should I bother? But there's disagreement about that. In your textbook, I think you'll probably see them putting in the return 0. Some people will argue, well, you should put the return 0 in there so that it's clear that to someone looking at your program that it's really there, or something like that. So whether you want to put it in or not, I don't care. I don't usually put it in. Question? I don't think that you're on the right track in terms of is it used in different places where it could cause problems. I suppose if you're saying we're going to be writing, so the question was, would it be good practice to put the return 0 there anyway, because there may be other places where we really have to put it there, and so we want to get in a good habit. I think that's what the question was. And there are going to be, in general, 3 or 4 or 5 weeks from now, we're going to be writing more functions that have this int in front of them, and in those cases, it's required that you have a return statement in there. So I suppose that's a good argument. You could say, well, you should get in the habit of putting a return statement in there because this is an int function, and you should get in the habit. I personally don't agree with that argument, but it's a good argument. So it's up to you. Yes? The return 0 is just returning some information to the calling environment, whatever that might be. So it's telling, like the operating system, for example, that if it's a return 0, that means that the program ran executed successfully. And if you want to tell it that there was a problem, you say return something else besides 0. But in our case, in this class, there will never be any occasion on which that will actually be used. And anyway, like I said, the compiler puts it in there for you anyway. Any other questions about the return 0 or anything? Go ahead. Yeah, if you wanted to put it in, you would say return 0. Say again? Yes, it's not for us at all. It's for the operating system. And it's a pretty subtle concept in terms of like what it is that is, what part of the runtime environment is it that's actually using this return value. We can use operating system to kind of refer to it loosely. So my suggestion at this point is that you either decide whether you're going to put it in or not, and then forget about it. Yes?
I've noticed that there's certain places where you leave spaces empty, like during the name, between the using namespace STD and the main. Is there a reason for that you have to leave an empty space?
Right there?
No, like
right there? Oh, blank line. That is just to try to make my program as easy to read as possible. Does that make sense? So if I've got everything all bunched together, it's harder to read. So I try to figure out lines that kind of go together, and I bunch those together and leave space between them. Yes? There's no significance in terms of how the program is going to run to whether there's a blank line there or not. C++ is going to ignore blank lines and multiple spaces. You can do as many or as few as you want. Okay, and just on that topic, I don't need a space there. I don't need a space there on either side of that operator. But it's better to put a space on either, in my opinion, better to put a space on either side of an operator, because otherwise things just get bunched up and harder to read. And so that's one of the style conventions. When you go and read my style conventions, you'll see I say, under the heading appearance, I say, put spaces before and after operators. Another question? Oh, okay. Yeah. And let me just say that on the style conventions, a lot of them are going to be, I'm not saying these are the only correct way to do things. Okay, what I'm saying is, in the real world, it's very likely you're going to work for someone who has requirements about how you write your code. So I'm going to give you a little practice with that. I have requirements for how I want you to write your code. I think it's the best way to do it. You may disagree with me. 90% of the world may disagree with me, but that's how I'm going to require you to write your code. And once you're done with this class, then you can write it however you want. Does that make sense? Okay. Any other questions about this program? There's my console window. The curly braces? Any significance? Well, they have to be there, if that's what you mean. They just want to say this is the beginning of the function and this is the end of the function. Okay, we're going to be using curly braces a lot in C++. In general, what they do is they mark the beginning and end of a block of code. All right, and this press any key to continue that's produced by this system pause call. Okay. All right. Moving on. Let's say that instead of just hello world, I want to produce this output. Can you see that okay? It's kind of a weird color. Okay? Let's say I want to produce that output. So I'm going to go back up here, and I'm going to say cout, it's sure cold out here. Okay, I didn't get the capitalization quite exactly the same, but bear with me. Okay, and let me go ahead and execute this. Yep, unterminated comment. This is where my syntax errors are going to be. If there's an error in my code and the compiler can't compile my code, so a compiler error is going to show up down here in this area. Right here it's saying, oh, I have a comment that I didn't close. And we haven't talked about comments yet, so I was kind of trying to avoid that. But basically I'm going to fix that by closing this comment. And compiling and running again. Okay, is that the output we were hoping for? Well, I want the it's sure cold out here to be on the next line, right? And then probably what I want is I want the pressing these key to continue to be on the next line after that, right? So I need to have some way of doing a carriage return or whatever you want to call it, like when you're in your word processor and you hit the enter button, right? In C++, here's how you do that. End-L, not end1, end-L stands for end line. And it's just like if you're using your word processor or whatever and you hit the enter button, okay? The enter key. And I'm going to put one down here too. And let me try executing again. Any questions before I go? Okay. Everyone understand what I did there? So in C++, if I say cout hello world and then I say cout it's sure cold out there, I've never told it to hit the enter button. It's just going to do exactly literally what I said, and the strings are going to come out right next to each other. So endline is how you do a carriage return in C++. Questions about that? Yes?
So you said that you were using that symbol to insert the hello world into cout.
Right.
So are you inserting the NL into the hello world?
Great question. Okay. So the question is, I said that I'm using the stream insertion operator to insert the string into cout. So does that mean I'm using the stream insertion operator to insert the end-L into hello world? No. The way, as it turns out, if I string them together like this, I'm inserting each thing into the original operand that was clear on the left. Okay? So let me just get really technical for a second, and if you don't understand this, it's okay. Right? Really what's happening behind the scenes here, think of this as the insertion operator is just an operator, like plus or times or whatever. So a little math review. Okay, Math 155 is a prerequisite for this class, right? So you should all know what an operator and an operand is, right? So if I say x plus y, what's the operator? Plus. What are the operands? X and y, okay? So in this case, I have you think of this as kind of the same as if I said x plus y plus z. It's just an expression with two operators and three operands, right? The way it works here technically in C++ is the first thing that happens is this expression gets evaluated. Just like if you had a plus sign there and it was 2 plus 3, it would evaluate and come out to be 5. Okay? So that expression gets evaluated. In the process of getting evaluated, hello world gets printed on the screen. And then the result of this expression is cout. Okay, this is the part where I said if it doesn't make sense, it's okay. But so when I go on to apply this operator, the second insertion operator, this part that I have highlighted over here has already been evaluated, and the result is cout. So what's happening now is it's like I'm saying cout end-L. Okay, lots of blank stares. So I'm just going to say that's okay if you didn't get that. What you really need to know is that if you've got multiple things that you want to print on the screen, you just go cout at the beginning, and then each item that you want to print on the screen, you go insertion operator, item to print. Insertion operator, item to print. Insertion operator, item to print, as long as you want. That's what you need to know at this point. And actually for this entire class, okay? When you probably like very early on in your next C++ class, you'll need to know that nuanced understanding that I was just talking about. But for this class, you're okay. Question there?
If I did cout, insertion operator cout, would that copy everything on the screen?
If you did cout, oh boy, okay. This is getting pretty hypothetical, but let me just answer that question. If I did cout, insertion. Well, no. The deal is that cout is actually going to be, if I said that, it's going to give me a memory address in the output. Because cout is actually something that's sitting in memory. It's an object. Okay? So it's going to say, okay, what's the value of cout? Well, the value of cout is a memory address. Okay? If I'm losing you, don't worry about it. Okay? You don't need to know this. We're just getting kind of hypothetical here. No. No. There's only one cout, and it's saying, find the value of this thing and insert it into this thing. And when I go to find the value of this thing, I'm going to find out that what's stored there is a memory address. Yes?
So hypothetically, you said that you could do cout, and then the insertion operator, and then row, and then the insertion operator, and then more stuff. Could you do cout, hello world, insertion operator, end L, insertion operator is circle out here? Would that work?
Yeah, so the question is, could I run all, so there's basically 4 items here that I'm printing out, right? Everyone see the 4 items? 2 couts, 4 items that I'm printing. Everyone see the 4 items? Who does not see the 4 items? Okay, I've got a string, that's 1 item. I've got an end L, that's 2 items. I've got another string, that's 3 items. And I've got an end L, that's 4 items. Okay? So I use 2 cout statements here, and that's good practice because what I've got here is going to appear on 2 lines of output, right? So it's a pretty good clue to the person reading your program that there's going to be 2 lines of output being produced here. But for neatness, is that what you said? Yes, for neatness or for readability. But the question is, could I just do that? And the answer is yes, I could. I'd get the same results. Let's try it. Execute. Okay, I got to close my console window before I can execute the program again. Okay, same output.
But since it's 2 lines, you want to show it in the program.
But since it's because it produces 2 lines of output, I'm going to show it as 2 lines in the program as a matter of good practice and making my code readable. Okay? Yes?
Back when you started, you said counting food, and then
Why do I have angle brackets around the word IOStream here? Because that is, well, the short answer is that's how C++ requires you to do it. Basically what's happening there is you're telling the compiler to go look for a file named IOStream, and it's taking the contents of that file and inserting it right here in your program. Does that make sense? That's what #include means. The angle brackets tell the compiler that this file that you're looking for is in the system folder someplace. It's in a special place where the compiler knows to go look for it because it's a system file provided by the system. Okay, that's what the angle brackets mean. A lot of stuff here that you don't really need to know yet at this point. That being one of them. Question?
Would there be another file, not IOStream, that the system knows where to look for it that you can put in angle brackets?
Yeah, there's a lot of them. Depending on what you need to do in your program. In this particular program, the IOStream is there because cout is defined inside that file. And endl is defined inside that file. And if I'm not mistaken, the insertion operator gets its definition inside that file. So if you don't include IOStream, you won't be able to execute this program. Later on, when we talk about other stuff we want to do that requires new operators and new reserved words, not reserved words, but new operators and new objects, you'll have to include other files that have those in them. Question in the back. Oh, before here? I hit the tab button. That is an issue for when you're submitting your files. Actually, no, you're submitting text files as attachments, so it shouldn't matter.
So later on it does.
Well, no, the reason that I sometimes make a big deal out of that is that sometimes I have you just submit your code in the body of an email or in a submission form, and then sometimes it gets messed up if there's tabs there instead of spaces. But since you're just submitting a text file, it shouldn't be a problem. Question?
What happens if you forget to add the semicolon at the end? It just doesn't appear. It'll just say like
It'll give you a compiler error, yeah. It won't execute. Oh yeah, sorry. Okay. Indel, the technical word for it is it's a manipulator, an I/O manipulator. Yes. Right. Okay. All right, I have a little bit more that I want to get through before we're done here. And technically I have 5 minutes, but I'm going to go over if I need to. Let's say that I want to produce this output. Okay, so I'm going to try that. Okay, what do you think? Is that going to work? What's the problem? Okay, so the first quotation marks. It sees so here's what's the bottom line here is you can't nest quotation marks. Okay, so C++. Let's pretend I'm the compiler here for a second, and let's try to predict what the compiler error is going to be. Okay, I'm the compiler. I'm processing the file. I get the first cout statement. I do the whole thing. Everything looks fine. I get to the second cout statement. It looks fine so far. It looks fine so far. There's my quotes to open a string. And when I get to these quotes, that's the end of the string. That's not what we intended, right? But that's how the compiler is going to interpret it. And so what could possibly come next after the end of a string? Well, I mean, in a correct C++ program, what could be the next character? It could be a semicolon to say that's the end of the statement, right? And there's something else we've talked about that it could be. It could be an insertion operator, right? But one thing it cannot be is another quotation mark. So it just doesn't make sense. So the compiler is going to complain. Let's see what it says, just out of curiosity. Expected. Here's the error. It says expected semicolon before you. Before the quote you. Okay. So now that's not exactly. If we were explaining it to somebody, that's not exactly what we would say, right? So sometimes the compiler errors, you kind of have to read between the lines a little bit. What it's saying there is, I expected a semicolon here, but I got something else. Okay? In this case, the compiler is not even smart enough to say, well, it could have been a semicolon, or it could also have been an insertion operator. Okay? And it's even a little confusing because it's saying it expected a semicolon before the word you, instead of, and there's probably better ways it could have said that, right? So sometimes it's hard to understand the compiler messages, but the compiler is doing the best job it can, so you'd be nice to it. Okay, here's how you fix that problem. Anytime in a string you have a character that you want it to ignore its normal function of, I know that was bad grammar, but I think you understand what I mean. You want it to ignore the normal meaning of quotation mark. You can put a backslash in front of it. That's called the escape character. Backslash. So I want that quotation there to be just part of the string. I don't want it to end the string, right? So I'm going to put a backslash there. And then this quotation mark here is also, I want it to be inside the string, right? I don't want it to end the string, so I'm going to put a backslash in front of it also. Sorry?
Oh, I'm just looking by the red. I think it understood that.
Right. Right. Okay? So it's kind of nice you can tell by the color coding if something's wrong sometimes, right? Okay, let's execute it just to make sure. Bob said you should wear a jacket, so that looks good, right? Question?
Instead of displaying hello world, if you wanted to display the C out, we put a backslash in front of it and then write C out and backslash instead of quotations.
Well, no. So you're saying, what if we wanted it to print the word "see out" on the screen? Well, we could just say, whoops, "see out." In that, whoa, what did I do? In that case, pity. We can just do that, because if it's inside the string, C++ just treats it as part of the string anyway. There's actually only two characters that you might need to use the escape character on. One of them is the double quote, because C++ is going to think that's the end of the quote. Okay? And then there's one other character that we've already talked about that you're going to have to do that with. The backslash, right. Okay? If you put a backslash in there and you want it to actually print the backslash as part of the string, it's not going to work. So if I want to print out a backslash on the screen, okay, if I just leave it like that, what that means is escape that quotation mark. I don't mean that to be the end of the string.
It doesn't know that you want it to end it there, so it's including
the semicolon's also red, right? Okay, so if I want to actually print out a backslash, I do backslash backslash. So those two characters that you may need to escape, the double quotes and the backslash. Question?
So if you say 3 backslashes, that last quotation with this turn left and not include.
If you did 3 backslashes, so what the solution is to use 2 backslashes. That's how 2.
So after the first one, like the second one's okay.
Right. So this backslash here says whatever the next character is, don't treat it like you normally would. Just think of it as part of the string. Okay. So this 2 backslashes is going to result in 1 backslash being in your string. Okay. And actually, in the memory of the computer has to store this string someplace, right? When the computer stores this string, it's going to store it as a string with 1 character, the backslash, even though there's actually 2 characters inside the double quotes there. All right, you'll get a chance to practice this in the assignment and during lab. So let's call it. Let's end our lecture here, and at noon I will see you in room 2806. It's down on the 2nd floor.